If you are a maker, chances are high that you have one of those. Right, resistors in a cabinet. Like us humans, they come in all strange shapes and sizes, and mostly they come with these color bands. By the way, I found this weird cube. If anybody has an idea what this is, let me know please. So how do you determine what's the ohms value on this thing? Well, you can look it up. And yeah, it sounds exactly as boring as it is. But if you look on the right side of this picture, there's a nice way to remember the colors, simply by remembering bad beer roots are young guts, but vodka goes well, get some now. I'm not sure what this means, but well, sounds funny. To be fair, if you're working every day with resistors, this gets in your blood. But for me right now, was it 5 now green or was it blue? I can't remember right. By the way, Richard on Learn Electronics Repair did a great series about basics like resistors. So if you want to have a real deep dive, get over to Richard's channel and look up the basics about resistors, capacitors and stuff like that. But then, one night at this fateful live stream we did, somebody came up with the idea, wait, these are numbers, so it's 0 to 9. Can't we do a clock with that? Well, let's see. And if you were with us on the latest live stream on Sunday, you already know the answer. Yeah, it can be done. To be fair, this started out as a thing where I simply wanted to put some boxes on the screen, and then it mutated. Big way. So let's get this thing running. So I'll connect it to my Wi-Fi over here, and then I show you the functions. So why the heck did I need Wi-Fi again? One word, NTP. Well, in fact, these are 3 words because it's Network Time Protocol. This is a way to get the current time from your internet. So I'm connecting this to the internet because I don't want to faff around with some real-time clocks things that I have to program by buttons. I mean, come on, it's 2024. Nobody does this. And since I hate to have fixed credentials in there, I use a Wi-Fi manager. This is a way to connect to a network without having preset your internet credentials. So this works this way. I need a phone for that. And I simply open my networks, my internetesis. And there I see resclock config. This is a network. Let's get there. Yeah, it's encrypted in German. Don't worry about this. This opens a capture portal, like the thing you have when you're in a hotel and you want to use your local network there. So we configure the Wi-Fi. And I'm going to connect to UMT IoT over here. There's the SSID. And then I have a password, which is really, really fancy, because it's 1, 2, 3, 4, 5, 6, 7, 8. This network is normally not active, so try to hack me. All right, let's go. Save. And now we wait for the clock. Before you ask, no, you don't have to set this up every time. Once you set a Wi-Fi network, it will always connect to the same Wi-Fi network. If you move out of the range of the Wi-Fi network, it will tell you, okay, I need a new network, and things are done. So there's our little clock in all its glory. Believe me, in real life this looks better. The camera doesn't do this justice. Maybe these little TFT displays are not that hot anyways. And another quirk on this one, see the blue light in the background, can't switch this off. This isn't a controllable pin, this is just simply the battery charger of this module. And sadly I don't have any control over that. So now it's 50 kOhms until midnight or something. Well, if you're just like me and you're lazy, you want to have a cheat code in there. So if I press the upper button, it tells me the current time. This actually is the time from the network that you see down there. And from here, for me, this starts to be something educational, because when you look at this long enough, you realize that one is red, orange, yellow, green, blue, violet, gray, white, black. This is something you remember when you look at this long enough and often enough. Sorry for the display, this is really horrible, man. So I hear you asking, how did you do that? Okay. If you're not into software, sorry, this was from here on, this will be all software, and I won't do a deep dive because there are so many functions in here. I tell you about the quirks I stumbled across, and as always, you can download the whole IDE from the link in the description. Just get one of these TTGo boards, I'll link in the description too, and these are somewhere around $10 US, comes from where you ship to, and then you can have this little clock on your own. I heard that Richard wanted to do something with that. I heard that Carlos wanted to do a 3D thing there where you could put it on a wristband. So maybe it mutates over the other channels. Let's see about this. All right, let's go over to have some software fun. And yeah, it's 2024 and I'm still in 1.8.19. Still no real reason to update and everything works in here. And big upside, I can get you this download link. The IDE in the description is exactly the same thing you see over here. Everything is presetted. Download it, start it, program it. You're done. This won't be possible with an Arduino 2.something IDE. If you want to port to 2.something, be my guest, please have fun. In theory, everything should be working. No idea if it will be. For a project, I normally do a dedicated IDE setup. And for this one, this came essential. Because of the stupid TFT display library. There's not much wiggle room when it comes to these libraries. There only is this. Wait, I show you this. Fact is, there's TFT ESPI and there's TFT ESPI. Use it or die. There's no real alternative to this one. So I stuck with that. And why I'm miffed about this? First, there is no documentation. I show you how I did my documentation there. To find out about my keywords, so my commands, I use the keyword text. This is normally a thing that makes the words colorful. So all the functions are in here. They find over here. There's no list. No freaking list. Nowhere on the net. When you use that, when you Google for that, you find something, but this is not sorted. This is all over the place. Secondly, they have a user setup in here. Why? Don't freaking ask. You set your board's parameters in this thing over here. Not in the source. You set it in here. So when you switch boards to a different one, you have to reset this in here. Why? Why the heck would you do that? There's no logical reason for that. With the setup I'm using, this doesn't hurt me because if I would port this to a different display, I simply would do another instance of the whole shebang. But if you have one environment in that you develop, and then you have to switch between them, you will go stir crazy, man. And this has so much potential for failure. I hate this with all my heart. Okay, this was my first real big struggle because this was a fight. It put up a fight, yeah. Documentation is over here. There's a LilyGo T-display board on GitHub. This is okay-ish. LilyGo was never really great with documentation. You see TFT ESPI. So they use the same library in here, but this is 10 months old. You maybe don't want to use this. Get the actual one and use this the right way. The one thing is really nice. The schematics are included over here. So if you want to have a peek what's going on under the hood, there's a complete schematic thing in here that doesn't load. That loads. If you want to buy from something else than AliExpress, I'll recommend tinyTronics from the Netherlands. They have really good support and they have everything in there. And this is real hardware. This is no fake stuff. They know what they're doing there. So shout out to them, guys. So great fun until this worked. When I had it working, from there on, this was pretty easy because what I wanted to do is simply using colors as numbers. So if you do an array, and you know the follow-up on the colors, so black, brown, red, orange, yellow, dark green, blue, magenta, dark gray, white, this is your selection there. And if you select one of these in the array, a 0 will give you back TFT black, an origin will give you back TFT free, or the other way around, you know what I mean? So from here on, the color decoding is pretty easy. But of course, I went down every rabbit hole I could find. I wanted to have a splash screen. Of course, I wanted to have a splash screen. there's a PNG thing in there that you can use for that. So what you see here is a splash screen. This is pretty much an array of pixel. I threw in a little PNG. You find this in the project folder, by the way. Then I needed something to turn RGB. So I'm used to thinking RGB, so RGB 8-bit. And I needed something to turn this into these strange color scheme they're using over here. So this is my routine for that. This simply shifts some bits over here and gives back a 16-bit 554 color thing. I can't remember. You see, this is already 2 days ago, so my mind is already struggling to remember. So there's some animation over here that does the color fade on the Wi-Fi question mark, and from here we're already in the clock. Let's see here. Okay, I do this the wrong way around here, but let's keep going. How did I get from the time to the actual colors? So we don't need clear screen. Draw the clock. This is the interesting thing over here. We're getting the time from the local network. The time would normally be stored in the TM structure, and that I simply institutionalize, is this the right word, and populate it with the current time. Then I needed to find out what value will be on what spot. And what I did here is this simple thing here. I take my 8-bit value over here, so this is an UNT8, and drop it into double digits. That gives me a string. If the double digits are smaller than 10, I know that the first letter would be a 0, of course, and I return a 0 and the number. That will get into the temp value over here. And then I have these little things here, the high val and low val. Let me show. And they simply check on what position in the string is what number. This is a way to return from a string to an int to int. That's why it says this. So after this, I have these little things over here, these colors. These are my 6 resistor bands. So from here on, I have these already set in the right sequence in the memory. So after this, I know my colors on screen. This is how long the bars are drawn on the screen. 135 is a full screen. If cheats are on, the bars will be only 90 in length because I need some space to put the text on. And I wanted to do this way. This little for loop simply draws my resistor colors with the bar length over here. Oh, there's one that we don't need because I started with simple rectangular and now I'm using filled round rectangle. Wow, fancy stuff. So if there are no cheats, I simply return, I simply skip out of there. And if there are cheats are active, I built this little string over here. Yeah, I know you can do this with printf. I was lazy here. And I wanted to have the double digits in here. I know printf can do this too, but again, lazy. Then I set the text color, set the fonts, and then I draw the center string. This is a really handy function once you found it and once you found out how it works, because this simply centers your text in the middle of the screen. This was really nice. So this is the whole thing to draw the clock. If this is fine for you and you simply want to know how this was done, you're out right now, because what we'll be talking about next is more the bells and whistles that I put in here, because there are a lot of bells and whistles. Okay, let's get through this. I knew that I wanted to have a Wi-Fi manager on here. We saw this with the phone. And I knew that I wanted to have NTP in here, and I wanted to have OTA over-the-air updates. So if you don't connect this to a computer and it's connected to a Wi-Fi network and your computer with the ADE is set to the same Wi-Fi network, you can program it without a cable. Fancy stuff, I know. I have this one button over here. This is simply to control the cheats on and off thing. And let me scroll down. And then we're already in setup. Okay. Display must be initialized first because we need this to output anything. Then we do the splash screen. And then we do the NTP stuff. Let's have a look at NTP. If you're thinking, why is there this strange construction with the double point? This is just for namespaces. So see this namespace? This separates all the stuff, and I know then in which of the H file is my function. So somewhere over here must be initialized, blah 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 blah, in a time, and it states explicitly run this before connecting to a Wi-Fi. So we're getting the blah 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 blah, and you're getting the blah 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 blah. The interesting part over here is the time zone. Where does time zone come from? No, really, where does time come from? And for time zone, this thing over here, I've stolen from the ESP8266 core because they have this fancy file in here, ESP8266TZ. These are all the time zones in the world. If you ever try to install Linux on something, this has a similar listing here. Yeah, and it's 475 lines, so loads of stuff. What this does is simply a define. It tells you America and Argentina, Tucumán is in time zone. I have no idea what this want to tell me. This is where I live, in the Canary Islands, so I'm in time zone Atlantic Canary, and this is my config string for the time zone. If you want to get into time zones, please Google as your friend. I won't go into this area right now. This is a very complicated topic. I'm way too old to try to get my head around this. But I know what I want to do, because I want to have this one here as my time zone. So I'm go back to the NTP thing and set constant char as a time zone Atlantic Canary, and this will get drops down here. So this takes care of summer and winter time, when you have summer and winter time in where you're living. And by the way, this is the one thing you have to change when you want to do this. If you live in the States, for example, you want to have something different there. If you live in Europe, you want to have something different here. If you live in London, by the way, it's the same time zone as the Canary. So if you're in England, you're probably fine. We initialize the time zones and the NTP stuff here, and then we need to connect to a network. Normally, we would do something like blah, 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 connect something, and this would be normally hard-coded. We don't do this over here. We have this little funny thing that's called Wi-Fi Manager, and this called Run Wi-Fi Manager. Let's have a look at this. Wi-Fi Manager is a third-party library. This is by Tiapsu or something, and I think he does a great job when doing this stuff. And yeah, everything is already stored in namespace. Wi-Fi Manager, let's have a Run Wi-Fi Manager over here. So I set some host names, I set the title. This thing, system pretty name, comes from over here. In W host name, you can't use something with spaces in there. So I separate between the system pretty name, where I can have spaces, say something like, this is my resolution, my resistor clock, and something where I need a WLAN host name, where I don't have kind of spaces or something. So this is my solution how to do that. Get back to Wi-Fi Manager. So the system pretty name will be shown on all the text screens in there, and the WLAN host name will be shown as a network name. The menu from the Wi-Fi Manager is normally way bigger. I only need the Wi-Fi network thing here. So I set this to this. I have a thing over here where I can reset all the settings. This could be, by the way, done. This isn't included in here with a double-click reset detector. If you want to be fancy to do that, I'll show you later how to do that. Okay, you put these things together, and this is the level I want to go here. Wi-Fi Manager, this page alone deserves a whole video. So without going into details here, this is how you connect to all this thing. When you at this point down here, you should be connected to Wi-Fi. This is the thing, this is the Wi-Fi Manager over here. And after that, we simply wait for the time. Let's go back to the start thing. So at this point, we know we are connected to Wi-Fi. I can start my over-the-air update. Over-the-air update, let's have a look how over-the-air update looks. OTA, init OTA, so have a look. Again, I set a host name this time for the Arduino IDE, so it has the same name as the whole system. So if I want to update something, I see this in my tools. This is connected to a different network right now, so I can't see this over here. But this is where this would be going. It's not necessary to have all these settings in here. You see this primary serial print, and serial print will only be connected if you have this connected to the serial port. But so this is a bit, do we really need this? This would work without all these settings over here. You simply can go for what's his face with this, and you will be done. So it's a bit over the top. I said I went down some rabbit holes here. This is my button management, and the button management over here does all the bouncing and stuff, and it does this all in one compact library. So I'm really happy with this. The only thing you do here, you have a button, you declare the button. And then you tell the thing attach click. So if I click this, this goes to a function called cheater. I think cheater is over here. Yeah, there's cheater. So cheater has one global variable, is cheats and not cheats. So this is a Boolean, so this changes between 0 and 1. When this thing's boot, its cheats is low. After clicking the button once, it gets high. After the button clicking the second time, it gets low. You know what it does. Then I clear the display. This is important. And I set old second to 0, old second to 99. This is a thing where I trigger a refresh. Let's see if I can show you this without getting you totally out of your mind. Because all these things are controlled. I'm already in the loop over here. All these things are controlled in the loop over here. And there's a function in NTP called every second. Is this in the right place? Could be better, but it will do. So here's my every second function. This will get called all the time in the loop. So expect this to be called 10,000 times in a loop. We don't want to activate anything every 10,000 times. We only want to do something every second. So there's a way to try to find this out. So I have this global variable that's called old second, and I simply compare it against the current second I have right now. If it's the same, so say it's 49 seconds, and I'm getting back here, and it's still 49 seconds, I simply return, I simply get out of charge, and I'm done. If it has changed, I'll update the old second to the new second, so next runtime, it won't go there. How to find out if NTP has set is you simply ask, is the time year minus 100 bigger than 23? We're in 2024, so this will always be bigger than 24. And if it's not, well, the time hasn't had set yet. I want to have a do this once thing over here, so I have a static here, and that clears my screen. Because after this, I'm going to paint all the boxes and stuff, and I needed this to be done once. Yeah, then I have some example codes over here that I left in. I don't need this here because the important part happens down here, because we go to display, draw the clock. This is the thing we saw before, where all the colors get sorted into arrays and stuff. To have the over-the-air capabilities ready, you need to have a handle running down here. This will get called 10,000 times a second anyways. And for your button handling, you need this too. So this is a classic example for no delays in loop. This is all controlled by points and either in time or events happening in hardware. You don't delay in these loops. So, well, how long did it take me to write this? About, say, 8 hours. And this was fun because there were a lot of deep dives in here where I thought, how do I do this the best way around? And what came out of this is a framework. I'll have this in your folder too. So if you want to follow me, please. In the sketchbook, you find a thing that's called ESP32, NTP, time, Wi-Fi manager, OTA, DID, EEPROM. I'll scale this up. And this file has all the freaking bells and whistles you just saw without a real function. So if you have anything that will work on time-based, so say the 1 second thing, you can use this easily for that. It has an additional double reset detector on board. So this can be used to kill all settings, for example. If you want to have some, say, for one reason, you want to kill the Wi-Fi settings by double pressing reset, you press a reset 2 times in a 10-second interval. So it clears all the settings, and this has as additional feature an EEPROM functionality. So Wi-Fi Manager is capable of packing in additional parameters. Let me show you how this works. For example, if you want to have a custom WLAN host name, you can have that. You would go add a parameter with this thing over here that will give you back a char string, in this case 40 chars long, will be added here. And the EEPROM thingy over here, there's a structure how to do this, and this will save everything, save crap in the EEPROM. There's no EEPROM, it's all fresh ROM, I know. And that way you can store additional parameters in your hardware, which is really handy. This is a really handy function here. Yeah. Again, these things alone deserve a complete episode of video because this is complicated stuff. If it's once it's done, this is pretty easy to use, and this is why I like this. I call it framework, because you simply throw this as a base into your program, and from there on, you simply build on it. This is how I do my stuff. And I was lazy for a long time not to writing this for an ESP32. I had this laying around for my ESP8266 for a long time. but this is a new thing. So, well, that was a freaking lot of software. I'm happy that you're still with me here. And yeah, I hope this wasn't too dry. As I said before, you can download this whole package down in the description of this video. You can get the hardware from the links in the description too. And well, yeah, I hope you enjoyed the video. And these little projects are more the thing where I'm invested in. You know, you maybe heard me talking about on the electronics channel about esoteric projects and more real life projects. This is more the things I'm happy with, where you can put bells and whistles in there without having something that nobody uses. This is the thing I imagine putting on your desk and having it sitting there, just to remember or train your brain for remember the color codes on resistors. I like this idea. Well, anyways, let me know in the descriptions if you liked it, if we should do more like this, if we should do more like the ESP thing that went totally to the roof, and I have no idea how this happened. As always, I hope you learned something today, and well, keep hacking and stuff, and I see you in the next video. Bye for now.